Well, I, uh, I was following a typical, depressions kid sort of thing about aiming to get a good steady job and something I enjoyed doing, etc. And so I got turned on when I was high school and early college about how radar was working and during World War II. And so people told me that if you could pass certain tests, the Navy would give you a year's training in electronics, learning how to deal with and maintain them. And that sounded very interesting. So I got drafted at the end of my sophomore year, but I was taking electrical engineering. And so I got into that Navy program, which was a year of training. It was very, very interesting to me. And then finally put aboard a ship, a converted freight ship, was heading for the invasion of Japan. And, with Marines and kids and everybody else, and nobody was nervous, of course, backing out of the berth and heading around San Francisco, and whistles, and they started blowing whistles, and we thought they say goodbye to everybody, and the captain came out on the bridge and shouted at us, Japan just surrendered. Yeah, so we all shouted, well, for Christ's sake, turn around, and like that. So 10 miles an hour, clear across the Pacific. But anyway, I was in the Philippines for a year, and so literally, while I was getting transferred from one place to another before I got assignment, it was in a camp just set up on the edge of the jungle in one of the southern islands, and so I found this hut that said Red Cross Library on it. It was one of these on stilts, on thatched hut, and I climbed up the ladder to look inside, and all nice and clean, and shelves of books and things. And I had it all to myself because apparently nobody else in the Navy or the Marines wanted to read. So I ran across then a Life magazine article by Vannevar Bush about his idea of the Memex. And it, I didn't get to do anything about it for years, but that really stuck in my mind. But so then years later I came back and finished college, and on sort of a whim, some recruiter from Ames Aeronautical Laboratory out here came by Oregon State College and interviewed, preaching the virtue of that, and we're hiring people, and I'd already accepted a job with General Electric in their training, but that sounds so intriguing, and since I'd been on Treasure Island as a sailor, I really liked this area, and I'd be right near Stanford and co-eds and such, so I impulsively said, okay, I shifted to come down here. So, so I was working, and after a couple of years, met this really, really charming gal and got engaged, and so the Monday morning after we got engaged, riding to work and thinking all this exciting thing about families and such, but before I got there, I suddenly realized I better start thinking about my job, and get this stuff in place. But the funniest thing happened that changed my life. It's for some reason what came in view was a long, featureless hallway, brightly lit, linoleum floor, fancy, and I think windows were on here, and every 20 feet or so a closed door to an office, apparently. It just went on indefinitely, and it just really hit me that that's my image of a career. I had no plans for what I wanted to achieve or do, and I says, oh boy, well that'd be something. Now I should start thinking about that. And sometime in the next hour, something else that came in, I have no idea where, but it changed my life. I just said, oh, hey, how about this? Why don't I make a goal that I will design and get a career that'll maximize the benefit my career has to mankind. See, that's what every 25-year-old kid will naturally come up with, right? I don't know where that came from, but that was the second big thing like that. And then it was like 3 months later or so, I've been reading about all the things you could do and all the things the world needs changing. And in every case, it just looks, boy, it's really complicated. And even the thing about saying, hey, how do I go down the street and advertise for a product manager for Mission Impossible, you know, goal or something like that? It's really complicated. And so one Saturday morning, all of a sudden, it just dawned on me, hey, these big problems that mankind has to face are all very complex, and they're obviously getting more and more complex all the time, and even more and more urgent, and they have to be dealt with collectively. And if our collective ability to cope with complex, urgent problems doesn't start improving, the problem complexity is just going to outrun and crash. Oh, that's what I'll do. Then I'll just commit a career to trying to see how we can boost our collective ability to cope. And that was probably March or April of 1951. And I had read a book about computers at the time, and the nearest one was in the East Coast someplace, either at Pennsylvania or at MIT. And but the thing is, I had all this 4 years of electrical engineering, and the training in the Navy, and especially the training with radar and sonar, in which you stare at the screen all the time, and the electronics puts things on the screen. And I knew if a computer could punch cards or print on paper, electronically you could put anything you want on a screen. And since radar sets respond to the operators pushing buttons and things, if a computer can read punch cards and such, it's just no problem at all in responding to things a computer or human would do. So you could do interactive. And it just got the picture of working interactively, and says, boy, that would open up a whole bunch, especially since you could probably have different workstations tied to the same computer complex collaborating in there. Okay, boy. So I got accepted at Berkeley for a PhD, or for graduate school, because they had a Navy contract to build a computer that they'd had it for 3 years, and the 5 years or so I was there, it never really got working. Big vacuum tube thing like that. But so what the whole chain of things for the next, let's see, I guess I got my degree in '55 and stayed there teaching, because I assumed I would just teach and be research. But early spring '57, I was very rudely treated by a kindly professor in a different department who we got to be friends with, and he just actually said, "Well, what are you interested in? What's your here thing research?" So I told him about interacting with a computer. He was very thoughtful, and after a while he said, "Well, do you know how promotion is handled in universities?" And here comes the really simple-minded country boy that I do that all the time. Gee, actually no. So he explained to me about peer review, and that if you can't get your right papers that get past a peer review group into good publication journals, you're just not going to go. He said, and I can just tell you now by this peer review that if you keep talking like this, you'll be an acting assistant professor forever. And I thought it over and asked some other people and believed him and left university. And then the thing is, I also, the highest tech outfit around was Hewlett-Packard. It had really blossomed during World War II and such, and I'd been familiar with its test equipment and such, so I approached them, and for PhD stuff I did do, I'd gotten like 10 or 11 patents, etc., and that impressed them, so they offered me a job right away, and it was all very nice talking to Hewlett and to Packard, and driving home, oh boy, I got offered a job. Oops. So I stopped and made a phone call back to Barney Oliver, the head of research who had hired me. He said, well, just as one simple question, I've been planning that I was going to really concentrate on computers, and and I assume that you guys are going to get into computers too. Is that right? He said, oh, no, sorry, Doug, not a chance. So that, oh, I see. And Stanford, I thought I'll just for the hell of it try that. And Dean of Engineering says, well, no, we're a small university has to specialize in highly academic things. And since computers are only a service activity, we don't contemplate ever having courses about how to design or build computers. So, at Stanford Research Institute, that got its name. They changed it to SRI later. But it wasn't part of Stanford, but they actually were designing and building a computer for the Bank of America to use for its processing, automatic data processing. And so I went there, and I had enough warning then that I didn't tell them what I wanted to do. I got hired, but it took years. That was 57. Right, but it took about 5 years before I could get a chance. And at the end of 5 years, I got enough of a goal to be able to write this paper that I call it Augmenting Human Intellect, a Conceptual Framework, so that I got more and more chance to think about what it is if you're going to try to help us think better and work better together, how you do it. And the prevailing terms so far had been of just growing interest in what they call automation. See, that the computer's going to automate different things, and especially later on automate the office. And so that automation thing, I said, I got a whole bunch of studies and thinking about, no, you come in and you change as much as it's going to change things. You don't just automate this because it'll change lots of other things. So out of this study grew this whole picture about how that artifacts and innovations in technology through any kind of history we can put together has come in steadily through that and made huge changes. And they change the environment and the way we work and the way we think and the way we talk and the way everything else. So there's a new environment that's different from what we thought. So, so, hey, the plow didn't automate the farm. It created farming, and then a whole bunch of other stuff started to happen as people settled down on farms and property ownership and this and that, and then pretty soon you had trade, and then you had villages growing up, and just a huge amount of change going on like this. So that if the computer's going to come in like this, it's not just automating, so this term of augmenting, and the whole idea about augmenting us, that the technologies have come in and augmented us, but so have all the changes in what I call the human system side. So you really then think about the co-evolution of these two sides, and that bringing in the computer to help think and the changes that could come into here there's a huge chance then to just really elevate the way we collectively can put together knowledge and learn about it and keep track of it, and even how we learn and how we can study and how we can communicate. And it's like the conflicts constantly with prevailing paradigms of it's for automation. So just year after year there was this struggle that I was such a, out of this world stuff, and it's like augmenting, just laughed at. And so in fact, it's like, it just happened that in the Defense Department had set up a new research group that I forget what its name is now, but there was a sort of out front thinker called Joe Licklider, who they imported from Cambridge, etc., MIT and Harvard, who had this idea about mind-computer symbiosis and how they would work together. And so he started giving me some money to get started. And there were things like, because of the strange nature of this report, that the managers at SRI were just really worried because all the reviews of this or something out this were, hey, this is just way off, you know. And so here came the money to have a small 4 or 5 person project to start implementing things. And so they told me, oh, we'll promote you to be a senior research engineer. Oh, that's neat. And then you sit here and think of more ideas, and we're going to put John in charge of the project. And oh, that was just a horrible year then, of just totally doing different things. And the next year was something else that didn't quite work. And the next year, oh, we got a platform of a small computer that could actually drive a display. And it cost us about $90,000 to build a computer display system that the computer could say where on a screen it wants to put what characters or draw lines, see? And the electronics to take that, position it, and it actually had to draw it because there wasn't anything like enough memory, high-speed memory, to do the bit mapping thing for that thing. And so that's when we got some money to sort of do some tests about what kind of screen selection devices, and everybody was betting on the light pen that was radar used and such. So we started putting together different candidates, and then I thought of some notes I'd made some years before, and we put that together and built it, and that turned out to be the mouse, and that won the tests. And so we started using it, and literally nobody can remember who named it first, nicknamed it the mouse, because I didn't think about giving it a name. And so we got won all the things, and then we started using it for the following years, and we were pretty sure that it would be the kind of thing that went out when people started getting computers, but it would certainly get an appropriately dignified name. But anyway, we continually battled this thing of somehow the very different picture that prevailed about what people thought about how these could be used. And so one of the things that we started making movies with this display, and 16 millimeter movies, and we put a shroud over that display and over here and set the camera up, and I'd have to get down on my knees and work it like this so that it could watch the screen and could get a capture of it. So we were actually starting to do then some word processing things, and so we could, then I found a 16 millimeter projector that could step or run at intermediate speeds or run at qualified full speed. And so we'd take movies of my game like this, editing stuff, and I started carrying that around, and you could run through and show them, look, here's a sentence like that, and we can replace that word, see? See, they're doing it like this and full speed. And so there was a meeting in MIT of the different principal investigators that were being supported by ARPA, and there'd been a whole summer study there about time sharing, where every one of the people invited, that had been several years before that, got a chance to give an hour talk. And so when I did, I was talking about how, you know, time sharing is going to provide a really new way of working, and I was getting into trying to describe it, etc. And I said, and we're going to be able to get benefit from response times down to 1/4 of a second even. The room just chilled, you know, ludicrous, see. So it was that kind of thing you're running across like that. Well, this movie showed it. So at this meeting, I got a chance to run this and show people. And oh, and somehow the guy that was running the office, his name was Bob Taylor, who lives out here in far now, afterwards says, well, you know, it really obviously hit people that they hadn't really thought I would do that. So he said, what would you really like? Well, I would like a time-sharing computer committed to my laboratory so we can do our work on it. See? Oh, well, okay. See, so that got there in 1967, late. So we really got things working at that time, and so there was going to be a computer conference in December '68 out here, and I just took a huge gamble, and I made a proposal to the committee that we get a 90-minute session and we would put on a real-time presentation, because I knew that there was this strange thing we'd seen of a gadget about 6 feet by 3 feet by 2 feet high that could actually project a beam and an image that you could trace like a CRT like this on a big screen. So we got all that set up, and boy, well, that was very nervous, because we had to, I invented a new way to get the computer screens up there like this of writing on a small 5-inch cathode ray tube, and because I'd read that that's the highest relative thing for somebody could get, but backing off the beam current so that it wouldn't erase the image in one sweep, so that the computer could write the image like that on it, and then the TV scan could take several scans before it would erase the image. So the computer would not have to rewrite so often, and we could run quite a few more from the same computer. And then the video would go out to just a regular video screen in the lab where our people would work. But this way we could just release 2 video lines with antennas up on the roof and a truck up on the skyline to 2 antennas, so we had 2 channels coming up, and we homemade modem from the terminal on the stage, etc. And so we actually started showing people, here's what you could do. So that was 90 minutes, and just by a freak that happened to be a guy there with a 16mm camera that he says, I can take it right off the screen from it, so it got saved. And so that's something that ever since then people look at, because it showed what we could do. We could actually collaborate with somebody, that they and we were both being able to look at the same image and talking on the phone together, and just a lot of things. So that sort of got us a chance to work. So that was in '68, so we got a chance to then get going. But then we actually in '74 started, the idea I had was you have to get communities working on it, and you can't just invent it in a lab, you got to get people working. So we actually talked everybody into, we would host servers, and this was a client server thing, and since you're working over like 300 baud, then 600 baud, modems, etc. So we had to build the absolute lowest technology client equipment that sent everything you did through 300 baud or 600, whatever it was, to the server, and what it sent back was just saying what to change on the screen. So that, with that very low bandwidth, could really work very well. And so people started buying this support, government agencies and the like, and we actually started getting them organized, etc., to start working on the improvement of that. And there were a lot of things that I was too naive to know well how to manage the group and how to plan ahead and how to keep sponsors happy. And I just think how naive I was. So things got rough, and a lot of the people would get angry with me because they wanted to do this or that, and I just kept feeling, no, this is the image I really have to follow. So there got to be more dissension. And then the really crowning thing was the office automation people were talking about the real users as secretary, and you got to make it easy to use for there. And I says, hey, the real user's tomorrow's knowledge worker, and we got to start talking about capabilities you can provide them, and talk about that first, and then as you learn to get more and more capabilities, you can start saying, well, that's very valuable. How much can I reduce the learning costs, but not have some artificial learning cost etc. So that we really got clobbered that year. Then, so in 1977, it just all fell apart. That the reviews we would get when proposing for, there would be two character fields. One is the office automation people were saying they're so hard to learn, you know, and the other would be the artificial intelligence people who were seriously pursuing for years that they were going to make the computer so smart that they would psych out what the user knew and adapt to that, so the user wouldn't have to learn new things, not like our stuff, and we just boom. So yeah. So anyway, so then we
Don't
yeah.
lose it. I'm gonna move it up just a little bit. You tell me. I don't think it is. It's right on the edge.
Yeah, because he was touching
It's really sensitive. All right.
Is this taking too much time?
No, we're doing good. We're starting to catch up in the future, right? I mean,
Yeah.
I think it's so fascinating that you're this pioneering evangelist as well, of getting people to understand the benefit of the possibility of moving in these different directions of the unfolding possibilities made possible by the computer. Where it was going.
But
I know you were involved in getting people to understand the benefits of word processing in that way.
Well, it's the whole thing.
You were on the edge, wherever the edge was going.
Yeah, and we happened to, since I was getting money from ARPA, and they would periodically have the principal investigators meet, and there was this one particular meeting, I think it was early '69 or someplace in there, that at the University of Michigan, that they told us that they were interested in doing this network stuff and tying computers together with networks so they could change. And the whole orientation for their networking was that you could share data, like if my computer had a bunch of data that yours needed, we could get it, or this one had the computational capability with some kind of programmatic thing. You could ship your data there and get it processed and come back. And this was the big orientation they were pushing, and I listened to it and thought, oh boy, you know, the collaboration, but that wasn't the picture at all. And I just, there was something that happened over here next to me. These two bright guys, thinking, Jesus, they're both pretty, you know, pretty much hard for either of them to believe anybody else had too much going on. So one of them turned and said, well, what do you have on my computer on your computer that I could use? You know, his ego was such, how could that be? This guy's ego. So he says, well, don't you read my reports? Because he knows pretty well that guy never reads anybody else's reports. And this guy says, well, do you send them to me? Because he knows this guy has no ideas where his reports go. And they both realize that's not going to work. So they both turned to the two guys from the ARPA office, two men running that office at the time, and says, well, you're going to have some way to keep us all informed about what data and equipment or processes each of them has and how we get at it. They hadn't thought of that. So then I volunteered to run a sort of a network information center that was sort of then get me along this line I wanted. So, okay. So that led to our being connected as the second computer on what's now the internet. And so anyway, so we were just really, that was late '69 or something, but by '74.
So you hooked up the second computer to the internet, or it made the internet, because the internet couldn't be with one.
Yeah. But anyway, so then by '74 we had matured enough so we could start delivering service over the network, but by '77 we got crashed, and fortunately we had about $1 million a year actually business of selling service out there, so a small part of us could go there, and a number of people had been going over to Xerox Park, but there it was there just seemed to be no interest at all in the kind of things we're doing. And they had this, by then they came up with using high-speed memory, they could do the bitmap stuff. And well, it was really glorious. And say, okay, this WYSIWYG, what you see is what you're going to get when you print. And I couldn't help but starting to say, yeah, but that's all you see. You know, that's old-fashioned technology. Because we'd been, some of the mid-60s, the very first thing we were doing is, hey, if you're going to have hyperlinks, we didn't call them hyperlinks, we call them links though, but you could point to any object, not just to a document, see, because when you're reading things in journals or something and it cites some other article, oh, they just cite the article, of course. You know, as Joan said, and cite the article. Well, hell, you'd like to have it point right to the passages that you're talking about. So we did that. So actually the link for us could point to any object, a character, a word, something like that. And so we started naming the kind of objects and their groups, etc., too, in a hierarchy fashion like this. And then we also said another thing that the old technology can't do is provide optional views. So the very first thing we built was, hey, just show me the first line of every paragraph. You know, oh, that's the one I want. So jump to it and open it up. Boom. See? And so those viewing options just kept evolving for 10, 15, 20 years after that. And the kind of way you could designate them with just a few strokes of a character. And so every link had a place in it syntactically that you could put the view specs. So you click on a link and it would take you there with a given view. And then we got multiple windows, so you could actually say, I'm jumping on a link in this window, and it's a double click thing. I say I jump on a link with one click, and then I move the cursor over to any window I want and do that final click, and that's where it appears. Well, then we can say I want to just jump. So I want to jump to that thing. And again, I could move the cursor, but I could also add some characters that changed the view when it got there. And then the addressing got more and more flexible, that I could say, oh, I want to jump to the last file, the file just before this one that was in this window, and I want to jump to the third paragraph that was on there. So we had addressing for that. And then, well, why, if we're going to do editing and stuff, do you always have to point? Why don't we use all that same addressing to do all the editing? Oh, I see. So you could sit here and you could just reach across and copy a whole chapter from someplace else, just come here like this and viewing it. So all that grew. So yes, it looked very complex when people were using it, but it's
Object-oriented thinking.
yeah, just take the shift in thinking. So you try to tell people, and it just didn't work. So anyway, that's that we got pushed out, and the prevailing thing about ease of learning, etc., has been dominant all this time. And the cut and paste, etc., which were things introduced way back in the early 60s by some people, cutting and pasting and such like that. And so I got to talking about, well, this is the prevailing way on the screen today is like Pidgin English. You know, ugh. Instead of, I want to move that over to there. And so the vocabulary, so we actually fixed it so that the vocabulary could grow, that there was a profile file that every user had, and it determined when you logged in, booted up, what was the vocabulary you offered. And so you could start with a very simple one that people could learn very quickly. And then as they got to wanting, they could add more verbs, more nouns, more addressability. And that turned out to be irresistible, sucking people into learning, because they'd walk by and see somebody else doing something. Well, how did you do that? Oh, we had a verb called transpose. You could get it too. And click on 2 words and interchange. Click on 2 chapters, interchange. And you know, try to see how much cutting and pasting you'd have to do to interchange 2 chapters. See, you could. Anyway.
So you developed a way of describing the inner structure of documents and files so that you could move sub-components around fluidly and easily.
Right. So the vocabulary grew, and we realized later that it's a lot like the object-oriented programming. Yeah, so that's what I was in a conference in Norway a month ago on object-oriented programming. So I went there and gave a keynote talk about, how the parallel is like this. And so I have a strong feeling that options like that have to be introduced. And
it's interesting that it didn't come from the programmers in that sense. You were actually exploring how to create the structure that would become object-oriented programming in this outer world of the actual text and content, rather than at the inside out of the programming point of view. But the programming ultimately caught up with you.
Well, I don't know. I don't know if
caught up with that. That's
with that kind of concept anyway. But so then with me then has evolved since this augmentation thing. There's even more to it. It's like saying in here, say, well, it's kind of strange, isn't it, that the formalization of our writing gets up to the parts of speech and where what's the proper formulation for a well-formed sentence? And I said, well, what about a well-formed argument up above? Why aren't we into that too? And that will really help us. And the same thing as well-formed sentences. And in this viewing thing that I've been saying for years, well, I just can't wait till I could get the resources to get the computer programs now can parse sentences. Okay, let's put the different parts of speech in different colors or different size or something like this, and just see how long it is that it just starts soaking that up, and you just start reading faster and more comprehensive. And if you're scanning for something, say, oh, I'm going to all these subordinate clauses or something, let me just not show them when I'm really scanning for...
kind of embossed flags that will draw your attention to different levels of the structure that's in what you're reading.
Yeah, or just try it with color or brightness or something like that to just come in.
We've actually got an analog for that, which has to do with varying the shape and size of the letters themselves in ways that are morphic analogs of the variations in their sound, as a training wheels effect for those who read. Same idea, but applied to a different end of the scale.
Mm-hmm. Different modes of presentation, and that's when I just says that's why when I read your paper and stuff, it's saying, look, we haven't even explored. We've been so limited by the method of printing, that technology, that everyone thinks that's the way you're supposed to read. And it says, hey, the way that you can have a series, a flow of stimuli coming to you is just marvelous, the way you can do it in the rest of your life out there. And so now that we have these means for giving you these portrayals, it can be so much more fluid, flexible, like this. Why aren't we starting to explore how we take advantage of, and here I'm sort of embarrassed that I haven't dug deeper into the brain functions and capability, but I attribute this perceptual kind of machinery. You get tactile and audio and visual stimuli, and what converts that stimuli into anything meaningful is, I've understood, the perceptual machinery that's in there. And here's one of the things that really interests me about your code process like that. It says, well, hey, it's like, that's why I brought this out for it. It's like this, a kid comes up, they learn that this, when they're talking, that's a bowl, and a fork, and a spoon, and a plate, and a cup. And how long do they have to look at this later on to know it's a bowl? Just one cliff like this. Well, that's the same way with everything else in your life.
Except for reading.
Well, this is the thing I was really then wanting to come to is, what's the difference? Are there other kinds of stimuli that the reader problems have, they have problems in this grokking quickly?
Yeah, I mean, here the difficulty is like children pick up, like you're pointing to here, 99% of the children have no difficulty recognizing an object and applying a name label to it. That's a shoe, that's mom, that's a lamp, that's a cat, that's a toaster. Problem is that they learn to do that with these letters. That's an A, that's a B, that's a C. But we teach them to do that in relatively stable, isolated chunks. When we put them together, hold the plate and the bowl together. When you put it together, it's no longer a bowl and a plate. What your mind has been trained to think of as a bowl plate, when you put it together, it's a cue stick. I mean, the meaning or the label that they've been trained to associate with the letter's name no longer applies to the sound that it makes when they're assembled.
Well, I'd have a really hard time then thinking that's a particularly unique thing in all the stimuli and things we learn in life.
I don't think that it's unique in the sense that there are other examples of it, but it's not. It is unique that to the child's experience at a certain stage of development, that faster than they can think about, they've been exposed to a code which has a number of discrete elements with discrete sound associates. But when these things are packed together into little packets and little strings, this letter sound, which they were originally trained to, no longer is applicable. It's only applicable about 40% of the time. These letters can now have entirely different sound values depending upon how they're combined and depending upon the meaning of the word, sometimes dependent on a word 3 or 4 words down the road. So this has to be buffered and worked out faster than they can think about.
Okay, and my intuition says we'd find a lot of things like that in domains that they don't have any trouble. You know, it's,
Well, let's go into that. Good. So what's an analog to something like that in the average 4 or 5-year-olds? Yeah.
well, how about just learning they learn how to talk.
Sure. They learn to talk. There's this incredible physiological somatic feedback system going on that's giving them feedback as they're expressing and articulating. They can hear it, they can feel it. When they're dealing with these letter sound equivalent processings, that's all virtualized.
Mm-hmm. Boy, okay, but they walk around in the rooms and such and just see all these things together. They don't have trouble because there's these books in this flexible pile there. Looking at it, it's a pile of books. Or I think about people driving automobiles and how much they depend upon, well, I'm pretty sure primitive people, when they're moving and running and fighting, etc. like this, a lot of dynamics that they have to get onto. And
sure.
So
but almost all of that happens in a sensorial, somatically sensible correlation to what they're doing, what they're thinking. Right? When we learn to talk, or when we learn to differentiate the sounds other people are making and recognizing the meaning, there is a recurring coherence to that. And in the case of them speaking it, they can hear themselves. They can say that I just made that sound. You know what I mean? It's when they're learning to walk and they're learning to touch something, they can feel it. There's proprioception, organismic proprioception, that's different than the kind of proprioception equipment to deal with a virtual code assembly.
well, I'd have to just, I'm partially swayed, but then I keep thinking, oh, that all of the subtle things that they learn, just the sounds in the kitchen. Oh, Mom's fixing dinner. And, things that go together without effort. So, well, here's some kind of questions that come to mind. Are there other perceptual difficulties, the children that have real trouble with the reading? Are there other perceptual difficulties they could have? I know 3 of our 4 children would have been lefties, and they all had trouble in school, all 3 of them. So what's...
Well, we've talked with people at the National Center for Learning Disability. We tried to gather up a perspective from many different dimensions on just this question you're asking. What is the correlation between reading, subsequent academic difficulties, and other modes of variation in functioning with respect to perceptual processing? How much seems to be neurobiological, meaning, how much can we say we can find a genetic footprint for in variation, or how much is a consequence of neurobiology and development, early on, as distinct from something that they've learned.
Mm-hmm. And is there also potentially emotional things of the kind of pressure about this new kind of learning?
There's no question that the emotional context, the peer pressure, the general assumption on the part of people in society that something's wrong with you if you can't do this well.
I just flashed back. An older sister, 3 years older, and so when I was 5 or something like this, they'd been teaching her the alphabet and such before school. And so my mother was trying to teach me, and I wasn't getting it. And it was really funny, because in later years my mother says, well, your dad thought, well, that's all right, he's just retarded. And
it still goes on, unfortunately.
Yeah.
I don't know if you saw these stats on any of our web stuff, but we're talking about 90 million adults that read less than 5th grade level. 90 million.
Boy.
This is having a bigger effect on our politics, our democracy, our economy, our social psyche, soul. In addition to that, 64% on average of 12th graders in the United States high school, for 12th graders, are below proficiency at reading.
60%.
Yeah. 88% of black 4th graders, 80% of Hispanic 4th graders, and in the 60s and 70% across all groups in proficiency with reading. Most of us don't see that.
Yeah.
They're the ones that are working jobs that their lives have been mangled and broken because they've grown up feeling ashamed
Right.
of their minds because of the confusion brought about by this challenge. And the ones of us that can do it just think, well, like your father did.
Right. Gotcha.
Sorry, I'm no trouble.
No, that's...
According to the president of Pro Literacy, which is actually the world's largest adult literacy organization, kids who grow up in a family where their parents are illiterate have about a 50% chance, half and half, of whether they're going to become literate citizens or whether, because of their circumstances, because of their home life, because of everything else coming against them from their parents being illiterate, it's 50-50 whether they're going to be able to step through this or be relegated into this level of life that they can live, of the kinds of jobs that they can get, which is enabling what they're able to do in life. They're relegated to that.
Okay. So I'm all of a sudden saying, oh, what can the stuff that I've been staggering along with?
Well, one of the things that I wanted to explore, and like I said, I really appreciate the opportunity to talk with you and get this history and just the wonderful lift you've brought the world in the way that you've pushed the envelope. And so I'm really appreciative of the opportunity to talk with you about that. And one of the things that I'm trying to do, in addition to getting the brain scientists and the academics of various kinds and flavors that are involved in the spaces that intersect in literacy and brain processes and so forth, is to step outside of normal educational psychology and cognitive science and all that. And just say, wait a minute, this is a code. This is a code. This writing system is a code. This writing system, I don't know if you
Well, I feel jarred every time I hear the term code, but okay, I mean, it just may take me up.
It's a contrived human invention
Yeah.
of associating a
No,
arbitrary...
yeah, I get all that. And it's one of the greatest inventions ever, though.
McLuhan said it best. I think he said this is the mother of all inventions.
Yeah, right.
It is.
Well,
I just interviewed Robert Logan, who was one of his partners. He wrote the alphabet effect with him. I mean, it is the most powerful technology ever released on this planet.
Right. So, does the same thing occur with languages that have very different symbolic portrayal? Chinese, for instance, or
Well, we have to look at reading. And nobody's done this yet. Your question is leading in a direction. I've asked people that nobody's done this very well. We'd have to build a grid to say, what are the different levels of confusion or ambiguity associated with processing these different codes, right? Now, in the case of the Chinese character system, as you know, and there's like 20,000 characters, it's a different set of mental tasks. The book that Logan and McLuhan worked on, The Alphabet Effect, actually compares Western and Eastern cultural, technological, civilization development and shows how both of them reflect this difference in the structure of their underlying writing systems. How the abstract combinatoric possibilities of the alphabet gave rise to Western science in a way that the East, even though it was more sophisticated in certain technologies, never got abstract science because their writing system didn't lend itself to it in the same way. It's very much the augmentation of society by writing systems and comparing the differences between them.
yeah,
So there's very much a powerful connection between that in terms of the exercise to self-reflective consciousness that goes with manipulating a combinatoric, ecological, low-number element system versus having to carry around this massive library of discrete, stable units.
so what,
The tape change.
our three kids were just, they said, well, this is dyslexia
Yeah.
kind of thing. So is,
95% of dyslexia occurs because of the way that children initially learn to read and what happens as their minds script into particular ways of processing, and then they develop different ways of feeling about how that's working.
yeah,
Only 5%, according to all the studies we got now, are neurobiological. 95% of the children that hit the wall, of the adults, all these problems we're talking about, there's nothing wrong with those people. It's how we've unfolded this ramp into this code processing.
that's terrific.
What we've got to do is recognize that, I don't know, as you probably aware, the alphabet's 3,500 years old. But the alphabet itself isn't the problem. During the days when it rose to become the OS of Greek civilization and the Romans and what have you, it was phonetic. One letter, one sound. It was very simple. The kind of challenge, neurological processing challenge that we experience today, our children experience today, it only came into existence about 500 years ago when the Roman writing system and the Latin sound system collided with the English spoken language system under the rule of the French. and nobody was minding the store. And a handful of scribes working for a king of England in the 1400s who spoke Latin and French, who didn't speak English, who didn't care about English, were the ones that started to transcribe English spoken sounds according to the sound and letter values of the Roman alphabet. There were 40-something English sounds, but only 20-something Latin elements, and they just did the best they could, and the heck with it, who cares?
Boy, you might get some technologists to find out that history is an interesting subject.
Especially the history of the technology that's at the root of so much of what's going on in our world. I hope so. But I mean, we're better to start than with some people that have been outside the box thinkers about the fact of technology's augmentation of the human mind and culture. Well, this is it here too.
All right. So I've been having enough trouble trying to get the world to hear about the factor I think would help, which would help the ones who already know how to read. So how could I do some shifting to have a chance of helping what you're doing?
Yeah, that's a wonderful question. I really appreciate it. But, Anne, let's go back to when you make a computer code, when you talk about all the different things that you've worked on. We talk about a modem, for example, or other transception systems or transceiver systems for sending and receiving information. There's usually systems designed to minimize the amount of ambiguity that has to be processed, the amount of confusion that has to be processed. I mean, the modem works because it knows how to interpret a string of variations into something that's a stable values.
Mm-hmm.
We wouldn't think of sending modem information and say, well, you'll figure out what the value of byte, the bit 3 of byte 4. We're going to tell you what that is, based on 25 bytes down the road, and it's bit 7 value. I mean, there's such complex ambiguity, such many levels of ambiguity in this code processing that's going on in learning to read that a good reader takes totally for granted. And so,
yeah.
And so, one of the things that I want to see happen is for the people that understand code in the technology dimension of our world to start talking about this code. Not just the linguists, not just the reading teachers. I mean, I've met with the best of the...
So, what kind of changes would be practical? I mean, do you think actually different symbolic portrayal of words?
There's no question. I think in the future, when we get away from paper being the most pervasive, learning environment, that the alphabet, our writing system, our modes of communicating are going to morph into something altogether different. Unfortunately, we don't have any technology that's sufficiently pervasively available to be an alternate learning to read environment for the majority of the people that need it the most.
But you could do some experimenting.
Yes.
To find it.
We have, I feel very drawn to go to this. We have actually developed and I normally don't talk with people about this. You're one of the few people that can really understand this well. We've developed a way of, like I said earlier, of taking any English document, scanning through it, and morphically varying the visual appearance of each letter. So according to a series of rules, like there's bold, italics, underline, which are general sets that give a bias shift to how you perceive. So we've done the same thing on letters. So that instead of having typeface, we got letterface. 6 variations that allows us to bloom or morph the appearance of a letter to suggest what its sound variation is visually, to reduce the amount of confusion to take off and read.
Have you got some, you've experimented with that to find?
We've got experiments that are beginning to start up. And normally I don't talk about that because that's a solution path, and one of the things I don't want to do is distract people from understanding the dimensions of the problem by being dismissed for having advocacy for a particular solution. So I'm moving on different tracks with those.
Yeah.
But I've got universities that are interested in that, and I've got technical partners that are beginning to become interested in that. But what I'm like I said, what I'm most interested in is getting thinkers who care about mankind, like you started with. I mean, that's where the two of us meet in the heart. You said in 1955, you're asking the question, what I want to do, and item number 2 is I want to do something that helps everybody. That's the mission of all of this, is to try to, I think our society needs to have a radical reframe in how it thinks about the challenge of learning to read, to see it as an artificial, technological code interface process that's unnatural to the nature of the brains of these children, that's overwhelming many of them with a kind of confusion their biology does not know how to deal with.
Is there, I wonder if there are any kind of tests that you can provide them with to find out if you can isolate what are the particular things that get in the way for them.
There's no question, if you spend time with a child on the edge of their struggle to read, the stutter, the articulation stutter and the hesitation stops of their flow, that it corresponds to the ambiguity fluctuations in the code. They must have a good level of oral language processing capability, for sure. And people that have too limited a vocabulary at their oral language level, people that are too slow in processing oral language, and that are exposed to the challenge of reading are in real trouble. If people are exposed to the challenge of reading in a language that they don't have some oral facility with, they're in trouble.
Right.
But even those that are more proximate in that they've got a good fluid oral language command at a certain level, can still have a lot of trouble taking off and reading. I mean, again, processing reflexes have to form that will buffer up a stream of these characters that are being read, and then disambiguate their letter sound correspondence values based upon this kind of coimplicative looping that's going on between letters and words in this span.
Right. I hear that and they're very meaningful. Then I think about the general sense of evolving and facing all of the basic sort of challenges children everywhere are going to grow up through. You know, before there's enough technology to have writing and printing. So what would differentiate the kind of kids that can learn how to read easily from those that don't?
I think the central thing is processing frequency. How many cycles, how fast are they able to cycle through the confusion so they have a better chance of getting through it before their attention breaks down?
Boy, well, if there's some magical way to get objective tests or something.
Yeah, there's tests going on. I mean, I think this part of the conversation is pretty clear. Unfortunately, and I don't mean to take too much time on this part of it, but there's a history here. See, when the English language collided with this collision happened in the 1400s, it didn't matter until the 1600s, really, when they started printing Bibles and started asking why are so many people having trouble to read. Benjamin Franklin invented a new alphabet. He thought it was as important as re-architecting the Constitution. He developed a new alphabet that aligned everything up so it would be phonetic. That's where Noah Webster came from. He was a student of Franklin's idea and genius for how important it was to shift this code before it would mess up further and further generations.
Gee, Franklin was one of my heroes, and I read this big, thick autobiography and stuff, and I don't remember that.
The one by Carl Van Dorn?
No, well, the autobiography.
The one by...
no, not a biography, an auto.
The autobiography, yeah. He didn't mention it a lot, but it's in his letters.
See, that's amazing.
Yeah. Anyway, there was a time in the 1880s, Melville Dewey, the guy that put the decimal system together, he gathered a worldwide group that included the presidents of every major university in the United States and in England. It had Charles Darwin as the signatory, later H.G. Wells, William James, the American psychologist, Mark Twain.
I'm parallel thing, I'm hearing all that. I'm pretty sure I'm hearing that, and this stuff's going on like this. Is saying, okay, so here I want to augment people like this. And he says, oh, but I've been assuming that, what is it, this 50% or something that can read well now, take up like this. It'd be very meaningful if we could bring everybody up.
Yeah, and not just because we want them to read, but because we want them to not be unhealthy in their own minds. It's the negative collateral effects here of
well, there's that too, and I can admit that that's important enough to say spur people to do this, but you think the kind of things I've been saying too about if we're going to get collectively smarter, that we have to have enough of our population be able to understand things that they can't be so easily misled.
Yeah.
And
participating in politics, solving ecological issues that we're facing.
absolutely.
Whatever social issues. It's amazing how interconnected this is to a huge portion of the population just dropping out and not really participating.
Right.
And then when you, we don't mean to bombard you with statistics, but when you really start looking into this and you say, oh, okay, excessive teen violence, excessive drug use, teen pregnancy, dropouts, when you really start adding up,
there's a lot of correlation.
Society, the correlation to reading difficulty is really big. And where we're coming from, it's not just because, oh, I can't read. It's because of a fundamental shaping when children are 5 and 6 and 7 and 8 years old, the ones that really are having trouble, that start relating to themselves and talking to themselves, saying, you know, I'm stupid, or I'm just not smart enough, or I just can't get this, and all these kids in class can get it and I can't, and what's wrong with me? Like when that repetition starts, what happens to society? What happens to humans when they start talking to themselves in that kind of a reflection of a relationship with themselves? Where
Well,
if we look around in some way.
it's just terrific. Okay.
Anyway,
I'm
share that. That's my.
It just sort of makes me feel sort of, oh, here I was off on this esoteric thing, and we can augment way up. And I really think there's a lot there to go. But if you could only bring along a small percentage, so how do you augment the rest?
yeah.
So that's.
How do we? Because we got to use what you're talking about to fold back on the people that have a listening and that can work together to change things for the people that we're talking about here.
Well, to me, the alphabet was one of the big augmentation things that appeared. We're talking about augmenting our intellect. So if it isn't working that clearly, well then it's a part of the same problem. So I'm grateful. But it's sort of like the first thing I think is, well, that's a complex, urgent problem. And
Yeah, it is a very complex and urgent problem. One of the statements we have in our website, I read it, was that more children in this country are at risk for serious life harm because of how they go through this corridor of challenge about learning to read than from parental abuse and from every kind of physical and psychological developmental disorder combined.
Yeah. Well, I'm sold. So.
Okay, I don't mean to keep selling.
So.
And it's costing us like almost $1 trillion a year when you add it all up.
Right. So. Yeah.
Yeah, I'm always back to the fulcrum. Where's the fulcrum?
Well, what have we learned about things that can facilitate people getting past that barrier? Because the business of changing the code, that's a horrific.
Yeah, that's where I was going with the story of Benjamin Franklin and all those guys, is because they made the best case in the world, and it went down to flames in 1906 in the White House.
Well, it's, if you can picture replacing our alphabet and everything, this is a huge thing. Starting it to evolve is another thing. So, but what are the means? What's learned? What are the means about why you can help the people? It's like you just think of.
Well, the traditional inertia, the reason that nobody wants to touch this, and the linguists don't think about it, and the educators don't think about it, and the educational psychologists don't think about it, because there have been so many attempts from the 1700s to the early 20th century to try to fix the spelling or fix the alphabet or add letters to the alphabet, and they all went down to insane folly. They were all dismissed. Webster, Noah, Franklin, Dewey, all of them. And so it got to a point where nobody would even think about it anymore. But the objections are all based on the fact that the only way to fix the problem was to change the spelling or change the alphabet, and that runs up against the invested inertia of the big institutions. Say, what are you, crazy? We're going to change the libraries and obsolete generations of the English language because some kids are having trouble reading? No way. So one of the approaches we're taking is to say, no, we can vary the letters in the way that we were describing to you in such a fashion that we create a third level to the orthography, an overlay to the orthography. It doesn't require some external code loop processing. It's embossed right onto the letters themselves. And that therefore, without changing the alphabet or changing the spelling, we can give another whole layer of information about how they're combining together in a particular word somebody's actually reading.
Oh, so that sounds great, but it doesn't give me an actual picture of what do. You start giving them something on a page that looks very different.
Right.
And well, can it be done automatically, like you feed old-fashioned stuff into a computer?
All fully automated.
So that this could be then a way where people are learning. And one question, if they start learning this other way, and they get fluent at that, can they then also have it sort of disappear and they could...
Yes. Just like, that's why we use the metaphor training wheels for literacy.
Yeah.
Just like you put these wheels on, and they're exaggerating variations in the shape of letters on an on-ramp up and an on-ramp down.
That's...
You can turn down like knobs, the intensity of them, or...
Sure.
But also using this in a way of helping teachers, reading coaches, tutors come into a different relationship.
Well,
right? That's what part of this documentary is about.
Well, how much different then is to say, hey, there are things that you could probably do, like I was suggesting, that could actually facilitate more rapid comprehension by people who already are deemed flexible readers or something.
Good. No
So
question.
Anyway.
Yeah, that's another whole question, which is once we're on the other side. The thing is reading has got to catch up with our oral language processing, and then it can go on to morph into something that's more complex.
Mm-hmm.
But the child initially learns oral language, and whatever the writing system is has to meet them there before it goes on to the next step.
So
that's where the breakdowns happen.
if there really are ways then that you can automatically transform the words, the characters, and something like that to something that doesn't come into this barrier, do you have any examples?
Yeah, I didn't bring it with me, but it's all over. I'll give you keys to that part of our website if you're interested in it.
Well,
basically, do you have some keys now? We call them PQs for. What we did was, rather than coming at this as a linguist who can use a computer and pattern analyzer to reconcile all the crazy combinations with which, there's 1,100 ways that we spell 44 sounds with 26 letters. And the linguist can all make sense of, we do this when this happens, and on Thursdays we do this, and they have all these patterns for it. But that doesn't help the 4-year-old or 5-year-old who's struggling with all of this. Mm-hmm. So we ask, what is it the child's confused by? What are the different kinds and classes?
Yeah.
Well, the first thing is letter names. We expose them to letter names, and we say this is an A. But later on when they encounter it, it doesn't sound that way.
It's
So
an
when
A
is it
or
a
an
letter
A.
name and when is it not a letter name?
Yeah.
So that's
Got
one
an
cue.
it's silent.
Right? And then when it's not a letter name, what are some of the other characteristics we can say about its variation? Sometimes it's silent. Sometimes it's actually not a discrete letter, it's part of a group that's making a unique sound. It's no longer.
So then there comes a big question to me is, do you think there's something sort of structurally different from the kids, or is it just the way they move in?
It's the way they move in and the speed with which they move in, the vocabulary they have, the time they move in, and their affective orientation to learning, how they feel about themselves and they learn all these things like a space shuttle catching a certain ride up into orbit.
For the majority.
Yeah.
For the majority of the 60%.
Then are there people somehow that there's something basically structural that they...
3 to 5% have
3 to
some
5%.
neurobiological structural issue that's affecting why they're having this problem. The rest of it has to do with the environment they've grown up in and how we've met them and taking them into the reading.
And that stat, the 3 to 5% is coming from the National Center for Learning Disabilities Director and the National Institute of Child Health
So,
and Development converging in on.
So what does it take to start giving them letting them start learning with a computer screen that's, or do you think alternative books that are made?
Actually, what we're talking about, the system that I envision in the future, even in our current constrained, computer availability in classrooms in urban school areas, etc., is that a child will spend a half an hour to an hour a week with a computer reading out loud. And the computer will diagnose the kind of, and assess the kind of reading difficulties that child is experiencing. And then we'll queue up everything that comes to that child, whether it's a math assignment or reading assignment or whatever, that comes to them from the classroom printer, so to speak, for them to take home on paper. Everything that they read will then be adjusted. So the letters, the spelling and the alphabet hasn't changed, but the morphing that we've talked about has changed so that it's cued for them and the kind of difficulties they're having with letter names, with silence, with blended, with combines, with segments, with the different classes of confusions that trip children up on the road to reading. Now ultimately it'd be better when we all got displays we can fold up and put in our pockets. But that's not going to help millions and millions of kids that are trapped now. We've got to do what we're going to do on paper, even though it's going to be all managed and set up by computers.
So this is very much the technical solution. This documentary is meant to bring people in. We're also working on a children's animation movie that moves through this to reframe this. A movie, a feature film experience for children to go to and their parents to go to that gives some light on the code, on the history of the alphabet, on shame, that there's really nothing to be ashamed about if you're having a hard time through this. So we're doing that. We're working with parents and teachers. We're building alliances with various learning and literacy organizations. So we're coming at this multi-tiered.
You ever heard of the Don Bluth Film Company? They did, 25 animated films, #2 after Disney. Anyway, yeah, they're a big. Yeah. So we're building an alliance of bringing heavyweight luminaries in different dimensions together to actually discuss what are the most important things, if we could do it, that we'd want to help children so that they came into this challenge better oriented, them and their parents. And then that's going to be the scaffolding that the commercial story generators get to work on in order to make a story and a movie for kids that will carry those things out into the public.
The biggest education outside of school.
Oh, I just,
Right.
this is terrific. just
Yeah, it's great. It's we love it. We're going to be another.
yes. It's like, well, why aren't you enthusiastic?
So, in your recollection, working on computers and being associated and around computers and what have you, there must have been some time that the computer, as it transitioned, I mean, even it's implicit in the Jacquard loom, it's implicit in machine operations that were going on before. This idea of programming, of a code, of manipulating representations rather than objects. And there's a little difference that has happened when we became conscious designers of programmatic code functions as distinct from the kind of process that gave us the alphabet and that gave us the written language system we've got. Like, they're two different kinds of human invented codes. One, there was a volitional, more critically minded, thoughtful process about the ecology and efficiency, and the other one was just unfolding in happenstance. And I want to get as close to the difference between those two as I can. If there's anything in there that feels at all comfortable.
I don't, somehow that
Doesn't connect.
No, and I'm slightly troubled by using the term code.
Okay. What troubles you about that? That's interesting. Let's just go into that.
Well, conceptual portrayal or something like this is a very general term that I've been using. How symbolically do you want to portray what it is you're trying to convey? And I've never thought of that as a code in sense, but so it could be a totally appropriate term to use. It just
we're trying to use it at multiple levels, in that most people say, especially today, post-DNA conceptual bursting onto the scene, we all realize that there's nature's full of codes, right? We think of it that way. There's a different order to that kind of code than there is to the kind of code that we work out to run our machines with. And this writing code system is somewhere in the middle. It's an interesting place, that middle.
I think we're looking for some term. Anyway, I'm just hunting around for this that is different from what people, how they think about language or something.
You mean not referring to this as a code?
Well, yeah, and
But
say,
even
no, wait, I'm kind of getting around to saying, okay, there's some term you want to do because there's a way to conceptualize it or something that's different from we don't have a language for it. That's when I was trying to hunt for, well, what are some of the things that would be more, what you'd assume, natural use of existing terminology that would be there. But
see, the Department of Education calls the front-end challenge of reading decoding. They actually call it that.
mm-hmm.
And my sense is that that's misleading, in that the problem isn't decoding in the way that a modem decodes a signal stream. The problem is disambiguating the code stream.
Well, to change the code stream.
The problem is working out the ambiguities so that it becomes a stable representation, which is different than simple decoding.
Or breaking the
So, quote, breaking the code is as if once you understand the code, it's all over. It's not. It's just.
Yeah, I don't know. It doesn't have to be any blockage or something for me to have somewhat of a trouble with using the terminology.
Sure. That could just be the pressures of history, right?
Or
it could be
until
very creative.
until I shift my code over to accept that code. Huh?
Yeah.
But well, I'm really also have some of the curiosity about what other kinds of tests might be given to the people that that are already demonstrated they're in this category, or the poor readers, or this or that. What other characteristics are there? Some basic characteristics you could test them with about what their basic sensory perceptual machinery is.
The most popular test has to do with phonemic distinction, being able to, if children can't make the sub-sound distinctions, I mean, words are co-articulated bundles of sound, but they have sub-sounds, and if kids haven't learned to discriminate, differentiate those sub-sounds, they don't have the internal assembly units to be regenerated and recombined to create the virtual inner experience we call reading. So there are highly specific kinds of tests that go at piece parts of this process to assess where a reader is developmentally. But none of them take on the code.
I just get an image now of we change the kind of children's TV that are there that are really working them through all these conditioning.
Yeah, no, we're working. I mean, on the one hand, we talked to neurologists, and they say the neurons that wire together fire together. And on the other, we talk to those people that say that the ABCs are running around in the mobiles of the 3-month-old, and their mommies are singing them ABC songs, and it's all wiring them and firing to set them up to have a confused response when they take off reading.
So are there video shows or something that could start giving them a little bit of appropriate conditioning?
Yeah. On the other side of recognizing we need to.
Yeah. Oh yeah.
Yeah, or there's really great video shows. One on PBS jumps to my mind where they're teaching match-up songs that work sometimes for the kids, but not always. And in these, I mean, there's really quality ones that, from my point of view, are also setting them up for confusion. So it's
it's a tragedy. It's a mass tragedy. It's like you've been struggling in your life, as far as I can tell, to try to get people's attention on thinking about these things, not just in terms of how they can be used to automate or advance the way we used to think, but as an enabling set to think in entirely new ways about things we couldn't think about before.
Okay, so I just generally say, hey, there's some very significant, complex, urgent problems out there. Let's get better at coping with them. Oh, you guys have been opening me up to see a complex, urgent problem. And say, oh, well, and
like I said to you on the phone, I mean, if we step back and look at the unfolding of human problems over more than a single generation, it comes down to how well the kids learn.
But one of the things is when we get them so that they learn like we've come to expect people ought to learn, and then there's a few more stages on down here about how we can work and learn.
Right,
And,
rather than assuming that with such arrogance, adultopomorphic arrogance,
yeah.
that the way that we've done it is the way that would ultimately be right for the nature of human intelligence in a complex world.
Yeah.
Because it's just an accident transmission like this code.
Well, well, for my next 50 or 60 years, I have to get my But it's one of the things it's just been getting to me this last year for some reason more than ever is, boy, I can't keep farting around. Things have to get moving.
Yeah. I feel more urgent every day.
Yeah.
I'm so glad that you've been out there and others like you kind of stretching the boxes in these different dimensions.
So, you know, I can't bend what I'm trying to do very much in order to help with this one.
Right.
But
I mean, appreciate your intention, but I didn't come here to solicit your help as much as to talk with you and share this with you and get your story as a thinker who's outside the box, who's been somebody who has been right at the core of what we would call the revolution of computers and code in our world, which makes you, in that way, very relevant to this conversation, even though this hasn't been a space that you've spent a lot of time thinking.
so it would be really interesting to say if there are parents who could afford, setting down the kids in front of a laptop or something and having them read with the new transformed things you're talking about, that would be one significant thing to do. And
yeah, we're in the process on that. So we've got a team at a university, and we've got a programming team up in Oregon, and we had some people in where would Alex come from? Romania. Building a website processor. We're doing parts of it. So that's one of the things that we're working on, and we've actually got prototype stage of it. But we're just now getting to get a team together to go out and try it in controlled ways.
as one of my basic assumptions, which I get shot at all the time, is saying, hey, the printed page is going to be, it's headed for obsolescence. And so with the new, there's so much more flexibility, and I did this marvelous country boy innocent sort of thing that I was to give a keynote talk at one of the annual conference of the Research Librarians of America or something, and maybe 400 people sitting there like this talking on. I'm saying, and it's just inevitable that books and print are going to go out of date. It's all going to be electronics, and I noticed that the chill. I just realized in a few minutes I may as well just quit, because. But it's.
Yeah, whatever comes is going to be built on what we culturally and cognitively and structurally learn by what they've been doing.
No, yeah, that would be the start of it, but it'd be very easy then to slip in, a transformation process that portrays it the way you're talking about. Yeah. If you say it could be automatic.
Yeah, and what we're saying is that, while certainly you could do that on a computer screen, we can actually do it on paper as well.
Oh, sure, you can print it that way, and that would be very interesting to see if, what would it cost for, up to how many grades, how many years would you have to provide them that before?
So far, our experience is we're going to do this with a lot of struggling adults first, because adults can get a first person. I couldn't read, now I can,
Mm-hmm.
You don't need to study it, they can do it really fast. But we expect that from a handful of kids we worked with in Oakland, and from just the other kinds of thinkers that have thought about this with us, that have talked about this, that kind of agree about it. It's never been tried before, never been done in history. One of the things that's come up is that once people get the cues teach them about a fundamental distinction, and they don't need them anymore.
Yeah, that's what I would.
Yeah, it's like it draws their attention to this distinction in combinatorics. But once it's clear to them, their need for it goes fast.
So what would you 10 hours, 100 hours, 1,000 hours?
No, that's got to be arrived at empirically.
Because even if it's something like 10 to 100, boy, that could be a...
Oh yeah, we think we can cut the cost that it takes to read, reading costs, down to 15–20% or much. I think theoretically we do much better than that, but I wouldn't dare speak to that. I think it'll be pretty radical.
Assuming that those costs were to take up the extra printers and
Well, I mean, schools, if a week of conditioning could make a significant difference, that's something.
Spending years trying to beat into the brains of these children all these screwball exceptions of how this works and this works and this works. It's kind of like telling them to carry around the traffic manual of the state of California's legal code or something as they drive around and figure out how to turn on a street.
So how long would it, what's your guess if you do some experiments where you get them to do this until they get fluent in reading that, and if they've been struggling with it before and show them this?
I think it's going to be on the order of 5 to 10 times more effective than anything that's ever been tried before.
Well, but I'm just trying to say, if you could say the remedial class they could take.
Well, you spent 10 hours with a teenager that is...
I worked with a 15-year-old boy who read at about first or second grade level. We had probably 20 one-hour sessions, 20 to 30 hours. And the improvement of him reading off of these cues that I was building in a slow one-person kind of way doing it, 20 to 30 hours, and his improvement was pretty incredible too. I don't know if you've ever sat with a 15-year-old stuttering through a basic children's book, but to cue this up and have him really reading through and drawing in and starting to, when he realizes he's at a place, giving him some kind of way to start working through it instead of just being confused and breaking down and holding his head and going, I can't do this, I'm just dumb. But to go, oh, okay, is it ah, is it a, is it oh, what's this symbol telling me here? To see that whole process happen so that he was kind of flowing on these traffic signs, so to speak. 30 hours, I saw a remarkable improvement.
And
he wasn't working.
What?
And he was one
somebody everybody had given up on.
Yeah.
He was so shamed out. We
And
tried
yet
with
he
little
still
girls
wasn't,
in Oakland that were 6, 7-year-old that were flunking out of kindergarten and first grade for reading, and they just couldn't read. And we worked with the Girls Inc. organization up there when we first piloted, started to tune some of this in. But I actually used it with my kids 10 or 11 years ago when I first invented the idea, when I first started playing with it, and it popped them both right through. So,
this is why we need to get. This is why we're getting a partnership with universities and the research. The research has to be done by somebody
to
else.
Substantiate it away from us.
Yeah, away from us to.
Well, I'm just trying to think at a strategic level of how big the problem is or something, and in order to change society so that as they emerge, that's what they saw is a huge problem. But if you have some remedial process, that at least you could provide it for those that could afford to have it or something. So it's a question like...
I think our best fulcrum traction on that score is the adult literacy organizations that are already got money and people that are working on the edge with adults that are struggling the most. And we just finished a partnership this week with the National Center for Family Literacy in Kentucky. They're the largest national organization for dealing with the whole family context of reading-related issues. We also have a great relationship with the president of Pro Literacy, which is the world's largest adult literacy organization on a planetary level. We have a
What's its name?
Pro Literacy.
Pro Literacy.
Lawbuck Literacy folded into them as well as the American Literacy Council.
Literacy Volunteers of America.
Literacy Volunteers of America. So, and we've had people like the director of the Institute of Educational Science, the #2 person at the United States Department of Education, who's responsible for the science of education, all assessment, testing, what have you, get this, what we're just described, and say, yeah, nobody's ever done anything like this. I think it's an original and unique and testable idea. Our focus has been to try to, have one spoke that's working on developing a solution path, but another one, it has to thump our country's consciousness into the inquiry, into thinking about this differently. And that's what the Children of the Code show's about, right? Is that this is, by the time we're done, we're going to have interviewed 100 people that are really the very cream of people working on different dimensions of the sciences that are implicate in this reading thing. So that there's no place to hide. If you care, you can come at it from this way or this way or this way, and you're still going to end up in this space with us. And then, of course, like I said, the animated movie that she was talking about, so we can get right to kids and right to adults without having to go through the more intellectual channel of a public television show or through the technical marketing side. So we've got 3 fronts we're working on.
So this latter one is, do you explain it again? The third thing you're talking about, is that?
The animated movie. There we're just acting like a distributed dialogue facilitator, connecting up different organizations and people to constill and distill a consensus about what can we all say is most vital here, so that they'll all be behind this information flowing to a bunch of creatives to make a kid's story that becomes the next Shrek 2 or commercial success, but carries these gems of jewels of thought about the problem with it.
So someplace in there I keep wondering is if they could find some actual technologically based remedial thing that hey, kids could spend 5 hours or 20 hours or something with this interaction.
That's in the first part that I described. That's the part of actually making this training wheels for literacy system. And we're still early in it because we have limited resources to do all the things.
Well, I know, but I'm just trying to think of, if that could be put into play and people could afford it, and hey, they can record real differences.
Yes.
Like this. This would do a lot then to say, well, how can we make it cheaper to get it to more people, etc. And
yes, and to get it out to more people so that it's not just the latest hooked on phonics fad, so to speak. It has to start working through the channels of the university and research, because as our school system has come to research-based methodologies, is what is in the masses of the schools. Other than just marketing parents outside of your child's problem.
Which is pretty much what I heard you saying, is there's parents that can't afford it, they've got computers at home, let's put something on there that makes a dramatic difference that they can see, that pulls a market together, and then let it spread out.
And we'd like to go with this.
But it's the same thing, that if it doesn't require interaction with that computer, then it can be put on a screen in front of a class or something, or. But anyway, that.
Yeah, I look forward to going into that space more, honestly. Yeah, I'm just busy in production right now.
Well, it's very moving, very stimulating.
I appreciate the time. I know we're kind of coming to wrap up point, and one of the things we didn't accomplish, and if you're okay with it, maybe the next time we're in the Bay Area, I would like to get together and talk again if you're okay. I'd still like to get more of your augmentation work theory on the other side of this. I mean, I came here not so much to share with you all the stuff that we're doing, but to connect you with this story as somebody who's a giant in the landscape of code and computer science and so forth, and to myself learn how to communicate across the gap so as to get us in the same space. I mean the gap in the sense that you've thought about things and been in this field in a way that I certainly haven't. And
Yeah, but I feel like I've been a consistent failure in trying to communicate.
yeah, but you've learned so much in that. I have
Yeah.
too. I've been pushing a boulder up the hill since the last time I saw you 12 years ago. Ask John sometime who I am. I mean, I've been crying out in the wilderness, screaming about learning and the health of learning and how do we get focused on that in a way. And so I feel a great kindredness.
Yeah, okay. Okay, brother.
That kind of thing. And so this is my, this is what we've come to try to create an environment for ourselves to learn our way into doing this. Because like you, I mean, we've got to embrace our frustrations as being illuminators of our learning opportunities, right?
I have to parse that. Yeah.
Okay, is that enough for today?
Yeah.
Okay. It's really been wonderful to talk with you.
Are you, let's see, I can find a report. Can I start getting untangled?
Let